Hi, Luis. How are you?
Hey, doing all right. How you doing?
I'm doing very well
Good.
now that my audio is working again. um, and so you've been doing a lot of F sharp content this week. This has been a busy month for you with F sharp.
Yeah, I think folks are tired of seeing my face already, so I promise you this will almost be the last time that you see it.
Almost. We do have one more opportunity tomorrow at our Let's Learn.net F Sharp event streamed on Learn TV. Luis and I will be your host, and we'll walk through the complete fundamentals of getting started with F Sharp. Yes, thank you. There's the link right there, aka.ms/letslearn.net. And we will see you there. But until then, Luis is here to talk to us about getting started with data analytics and machine learning in F Sharp.
Yeah, super
So
excited.
I will bring up there we go. All right. And I'll let you take it away.
Awesome. Thanks, Jamie. All right, so I am going to talk to you about data analytics and machine learning in F Sharp. It's almost like all the presentations before this. Basically, we're just queuing up my presentation here because I will be talking about actually a lot of the things that you've seen in previous sessions, which they've all been really wonderful. But if you don't know who I am, my name is Luis Quintanilla, and I am a content developer here at Microsoft. I work on ML.NET, .NET for Apache Spark, as well as Azure Machine Learning. So, whenever I get a chance to talk about both of the things that I really love, which is F Sharp and data analytics and machine learning, with a lot of these tools in the .NET ecosystem, that's sort of my happy place. But anyway, I'm going to try to get through these slides as quickly as possible because I know that you're not really here to see slides and you just want to see the code. But just to give you a brief introduction into what I'll be covering, basically, I'll first start off talking about the machine learning workflow and sort of, how do you build these types of applications. I'll then get into what the landscape looks like in terms of what are the tools that folks are using to build these machine learning workflows. Then I'll talk a little bit about sort of what's F Sharp's role, which I think you've seen some of the benefits that F Sharp can give you, and what the role of .NET is when building these AI applications. And then finally, I'll show you what that landscape looks like for building machine learning applications in .NET, as well as walk you through some demos, a full end-to-end example of how you can build a machine learning application. Okay, so when we talk about the data analytics and machine learning workflow, typically at a high level, it kind of looks like this, right? You start out with a problem, things like I want to forecast the sales for the next quarter, or I want to make some personalized recommendations to my customers, right? So you start with the problem, then you go out and you get some data that might be sitting in your data warehouse, or maybe you go to some other public sources or actually start collecting the data. At that point, you go ahead and prepare the data, and that means cleaning it from the sense of, you want to basically get your data and remove duplicates. You're going to join data because it's probably going to be coming from different sources. And you're going to get it ready for training or for modeling, which typically use different algorithms depending on the task that you're performing, right? If you're predicting numbers or if you're categorizing items, the task may differ. So according to your task, you're going to select an algorithm for your data set. Once you find an algorithm that kind of works, you want to go ahead and evaluate that your model that gets put out. A model is essentially just, you can think of it like a function that contains state based on the historical data that you've given it to train on. It's going to remember patterns, and it's going to remember patterns, and then based on those patterns, it's going to try to make predictions on new data that you give it. So you want to, first and foremost, you want to evaluate to make sure that the model performs the way they would expect it to. There's certain metrics that measure basically what are the differences between, say, a ground truth and what your predictions that you're making. And this is typically an iterative process, right? It's very experimental because sometimes you might go back and you might change the algorithm that you're using because maybe it's not right for your particular data set. You might either add more data, you might change the inputs that you're using for your model. So you might go back and forth until you find and settle on a model that you really like. At which point, once you have a model, you go ahead and deploy that model. Typically, this is done as a web service, right? But there's many different ways to deploy models. And then finally, once your model is deployed, you go ahead and make predictions. And again, this process of deploying and making predictions, it's also an iterative process where you don't stop. Once you deploy something, you don't stop there, because the world changes, right? So you want to make sure that your model represents the state of the world that it's sort of making predictions under, right? So to give you a perfect example, right? Let's say that you were running some sort of a tourism company back in 2019, and you were making forecasts for what your peak season was going to look like in 2020. And then all of a sudden, there's a global pandemic. So your models are no longer valid, right? Like they no longer work because the state of the world has completely changed. So you need to go back and retrain these models based on what the state of the world is now, and redeploy them, reevaluate them, and make predictions with this sort of new model. Right? So that's at a high level how you go about building these applications. What does the landscape look like, and what are folks using to build these types of applications? So the three that I'm going to focus on, or the three steps within that workflow, are going to be the data preparation, modeling, and deployment components. Typically, when you're preparing data, you might see folks using something like Apache Spark, especially when you have large data sets and you're doing it at scale. Pandas and Dask are very similar in the sense that they allow you to represent data in this tabular format and perform operations on that data. And then typically this data processing and visualizations and all sorts of things are done inside of this environment known as Jupyter Notebooks, which I think you've seen something similar before this, .NET Notebooks, right, which I'll be showing off later. And to get this interactive experience, right, then once your data is prepared, you use something like scikit-learn for training classical machine learning models. So think logistic and linear regression. You might use TensorFlow or PyTorch for training deep learning models. And again, this modeling might also take place inside of a Jupyter Notebook. And then for deployment, as I mentioned, typically this is gonna be done inside of some sort of it's gonna be done in some sort of web service, typically. So you might use something like Flask. Maybe you might containerize that web service containing your model using Docker, deployed to Kubernetes. So just like any other sort of web application, you have this sort of microservice for hosting your machine learning model. Or you might use other tools like Triton, right, for simpler for making predictions simpler inside of a GPU environment, right? So with GPUs, you might also use something like Torch Serve, right, for deploying PyTorch models, or you might use something like TensorFlow Serving for deploying TensorFlow models. So they all have their own sort of ways of deploying models. And you might also even consider Onyx, right? So Onyx, although it itself is not necessarily a way to deploy models, it is a way of providing uniformity and providing sort of interoperability across frameworks. So let's say that maybe you trained with TensorFlow or you trained with Scikit, and maybe you want to use it inside of some other PyTorch environment. So you might leverage something like Onyx. That way you have this sort of a uniform way of representing your machine learning models for deployment. With Onyx, the Onyx runtime, you can also deploy models very efficiently to devices on the edge, right, or IoT devices. So that's essentially a set of tools that folks might use in the industry. There's a few more. Again, this is not exhaustive, but some of the more popular ones. And one of the things that they all tend to have in common, there's sort of a common theme here. And part of that theme is that these tools either have strong Python support or there's Python exclusive, meaning, so for example, like Dask and Pandas and Scikit-learn, they are Python exclusive, meaning you can only use it with Python. And that makes sense, right? So some of the folks over at Anaconda, which is this sort of company and ecosystem for that builds tools for building machine learning models and for building these data science workflows, they did a survey recently, and they found that 63% of the respondents said that they always or frequently use Python. And because, again, this is the state of data science survey, I'm going to assume that, to finish off that sentence there, that they use Python to work in data science environments, right, or to build data science applications. And this is further corroborated by some of the folks over at JetBrains. They actually did a survey as well not too long ago, and they basically asked Python developers, what do you use Python for the most? And you can see that in the top three, you have machine learning and data analysis, right? So again, this further reinforces the fact that folks are using Python for these types of applications. Now, when they were asked, what sort of features do you like in Python? Some of the answers, these are the top five, sort of from most popular, I guess, to least. And you see that some of the things that folks really like are the simple syntax, the fact that it's easy to read, it's easy to write, it's easy to learn. You have generators seamless comprehension for working with data. You have libraries, kind of like I showed you. There's tons of libraries for these types of machine learning applications, as well as other types of workflows, right? Web, whatever type of application you're building. And the fact that it's dynamically typed or duck typed, right? Which I would imagine contributes to that sort of simple syntax and making it easy to read and learn. However, folks were also asked, what are some things that you would like in Python? What are some of the desired features? And again, this is from most to sort of least important, and these are the top five. And you can see that there's things like static typing, better performance, concurrency and parallelism, pattern matching, and a compiler. Okay. So if we are to take the fact that folks that are building data science and machine learning applications are using Python, And if we are to take at face value the things that folks like about Python, as well as the things that they wish they had in Python, what exactly is F Sharp's and .NET's role? Now, I'm not really going to go ahead and go through all this because you've seen tons of sort of demos how how wonderful F Sharp is and different features and things like that. But I'll just call them out, right? One of them, straight up, at the very beginning here, is the fact that you have libraries for any problem. In this case, I'm using F Sharp Data to get HTML and download HTML from some website, right? I'm using in this case, there's static typing. Again, there's a compiler that's sort of checking my code. And there's also type inference, which is probably the next best thing or the closest that you can get to sort of dynamic typing inside of a statically typed language from the standpoint of I'm not explicitly giving defining the types here, but the compiler is able to guess or infer the types that I'm working with based on the code that I have inside of my application, right? You have things like pattern matching, list comprehension, generators, and concurrency and parallelism sort of built in. So in terms of I'm not here to tell you that F Sharp is the answer, right, to everything. But again, if you are to take those things that folks like and the things that folks wish they had, right, you can see that with F Sharp, you don't have to make a lot of trade-offs, and you get the best of both worlds. Now, in terms of .NET and what .NET's role is, number one, .NET is performant, right? So it performs really well. The runtime is extremely performant. And also the deployment targets. So you can deploy basically anywhere. So you can deploy and build applications for desktop, web. You can build for mobile, IoT devices as well. And of course, you can build AI and machine learning applications, which is actually what we're going to be talking about a little bit more here. So what exactly does the data analytics and machine learning landscape look like in .NET? Well, again, if we go back to that sort of prepare, data modeling, and deployment steps within that workflow, you can see that we can use tools like .NET for Apache Spark, which is a set of .NET bindings, a library with .NET bindings for working with Apache Spark. So again, if you're already working with Apache Spark with PySparks so that's your Python environment, or you might be using Scala, right? Some of the native Scala libraries. Now you're also able to use .NET for Apache Spark to perform your ETL jobs and your data preparation processes at scale, right, across various clusters. And because again, Spark runs in a lot of different environments, this can be, basically in any cloud or any cloud, it can run inside of any cloud provider that has Spark capabilities, right? It's just a matter of getting sort of the .NET, the .NET libraries and the bindings, and then submitting jobs using the .NET sort of driver, right? You can also use the FS Lab set of tools, right? So Plotly and Deedle, which you kind of saw Kevin talk about earlier today. All right, you can use the FS Lab set of tools for preparing your data. You can use ML.NET to a certain extent, right? ML.NET has some transformations that you can filter data, you can impute or replace missing values. So you can do some data preparation inside of ML.NET. And of course, I couldn't find a better logo for this, but essentially the .NET logo here basically stands for .NET Notebooks, which is some of the notebooks that you saw in previous talks. For modeling, again, you also have ML.NET, and one of the things that I didn't really talk about in terms of data preparation, but I will focus a little bit more on here, is ML.NET. Which is an open source and cross-platform machine learning framework for .NET. And basically what ML.NET allows you to do is it allows you to not only train custom machine learning models, especially for classical and deep learning scenarios, such as image classification, but it also allows you to use pre-trained models. So for example, if you have an ONNX model, right, or a TensorFlow model, you're able to also make predictions with those inside of ML.NET. So it's really powerful in terms of it's not just ML.NET models that you can use, but you can also interoperate. Say, for example, if you're working with folks that are using other frameworks like PyTorch or TensorFlow or something else, you can interoperate with them inside of .NET applications using ML.NET. For modeling, again, you can also use the FS Lab stack, so you can use F Sharp Stats, as well as you can use Flips, right, which Matthew's going to be talking about a little bit later. You can use the SciSharp stack, which is actually part of it is actually used inside of ML.NET. Some of the TensorFlow bindings for .NET, TensorFlow.NET is inside of the SciSharp stack, as well as Keras library, right? I believe it's TensorFlow Keras, that allows you to build custom neural networks like you would with, say, TensorFlow or Keras, right? So that's how you would basically go about modeling using these libraries for modeling. And again, you might do this inside of, say, tooling like .NET Notebooks. And then last but not least, talking about deployments, again, you can use ML.NET to deploy not only ML.NET models, but also models that are in ONNX or TensorFlow format. You can, of course, leverage the power of ASP.NET Core and the performance of ASP.NET Core to deploy these services as web services. You could also leverage things like Xamarin to deploy, and well, I believe Maui is sort of the next iteration of that, right? So you could deploy these models to mobile devices as well, right? So there's a lot of flexibility. You're not only constrained to web services, you can really deploy anywhere that .NET runs. So there's a lot of benefits there. Now, let me actually get into actually showing you some code. And I'm going to show you how you can go about building an end-to-end machine learning workflow with F#. And basically, the tools that I'm going to focus on mainly are some of the FSLab tools, ML.NET, and .NET for Apache Spark. So let's get started. All right, so what I have here is I have a .NET notebook, and the problem here is essentially I'm trying to predict the scores of a restaurant inspection in New York City. So the data set that I got was from the New York City Department of Health. And basically in New York City, what takes place is their Department of Health typically goes out, sometimes maybe randomly or sometimes maybe on an annual basis. They go out and they perform inspections on restaurants, basically to make sure that the restaurant is sanitary and it's held up to standards, right? Now, throughout these inspections, they log if there were any violations, how severe those violations were, and based on that, they provide a score for that particular inspection that they then use to give a final grade to the establishment that will determine whether the establishment is safe to sort of dine in, or maybe at some point they might end up shutting down the establishment, right? So that what we're trying to predict is that score that's based on an inspection. What is the score of that inspection based on the violations and other inputs that we're going to have for this particular establishment? So we're going to start off with data preparation, and to do that, we're going to use the .NET for Apache Spark package here. And in this case, to install and reference that package, we use #R and provide the name of the package here, which is Microsoft Spark. That's going to go ahead and install it. Now, I'm not going to run this, so you're not going to see the code running live, mainly because this is actually a lot of data, and I'm running it locally, and with cameras and all, you can imagine that this won't be the most performant. So I'm just going to walk you through the code here. So again, I'm doing this inside of a .NET notebook. I install the package. I go ahead and open my package. I start a Spark session, which basically binds to the Spark engine that is running in the background. And again, I'm doing this. I did this locally, but of course, you could do this, like I said, at scale, right? Like you run this on a cluster somewhere in the cloud, right? But in this case, I did it locally. I initialized the Spark session, which sets up a connection with the Spark engine. I go ahead and load my data, which is in a CSV file, and I give some sort of options here telling it that it has a header, and I wanted to guess what the schema is. When we print out the schema, you're going to see that we have information. This CAMIS is basically the ID of the establishment. We have things like the borough, right? So in New York City, there's 5 boroughs, right? Manhattan, Brooklyn, and a few others. You have contact information about the place. You have description about the cuisine, when the inspection took place, right? So that's going to be important for us. If there were any violations, what those violations were they critical? And what we're going to be trying to predict is this score here, right? And we're going to provide different inputs from this set of columns. Okay. So the first thing that we want to do is we want to just kind of like we want to explore our data. So we go ahead and we check out the boroughs here, right? So again, there's 5 boroughs, but here you notice that there's this other 0, which maybe that's like a null value or invalid data. There's only 171 of them, so I'd be okay just throwing that information out, right? It's not significant compared to the rest. I think I have enough data here that it'd be more trouble to try to figure out, what each of these individual rows and inspection rows belong to. So I go ahead and I clean that up a little bit, remove that 0, and then I have this sort of cleaner data frame, right? And data frame in Spark is basically the way that you represent data in this sort of tabular format. Now, viewing my data in this sort of tabular format or this sort of textual way, I don't really like that. I want to visualize. I want to see plots. I'm more of a visual person. So to do that, I'll use some of the FSLab packages, right? This one here is plotly.net, and I'll go ahead and install that one as well, and then bring it into my application here, into my notebook. I'll prepare the data a little bit, right? Because I need to have sort of XY. I need to have values for my XY coordinates because I'm going to be creating a column chart here. And then when I go ahead and plot that, you see that I get this super interactive, really nice visualization here showing, in this case, it's how many inspections have been done across the boroughs. So you can see Manhattan has the most inspections, and then sort of it goes in descending order down to Staten Island here. Awesome. What if I wanted to visualize or plot where these establishments were? So again, I can sort of look at the latitude and longitude columns here, take those, this is kind of what the data looks like. There's some bad data in there, like some have 0 coordinates, which again, I'm okay throwing those out. And then I go ahead and plot this, right? And again, using Plotly, I get this super rich map and interactive experience for visualizing where these establishments are located. Okay, so now I'm going to sort of fast forward. Let's say I've done all my data exploration, and now I just want to do a query, get to the columns that I need, maybe perform some transformations. So there's this super long query that basically what it's doing is just taking a subset of the columns, performing a few transformations on them to make it easier to read and to feed into my algorithm once I start training with ML.NET. And I run this query. And once I'm happy with that query, I'm going to save it in this directory called process data. If you look at this process data directory here, scroll down, you can see there's a whole bunch of files. And the reason for that is the way that Spark works is it partitions the data and it sort of processes it in batches. So basically each data file here, each CSV is one of those batches that was processed by Spark. So you're going to see here, there's that information. Here's the boroughs, types of inspection, different sort of the violation codes and all types of information. So this is basically the data format that I'm going to be using to train a machine learning model to try and predict the score of an establishment. Okay. So now that we have this data, we ran it, we have our data process, let's go ahead and train our model. So to do that, we're going to be using ML.NET, and we're going to be using AutoML, so the automated ML functionality inside of ML.NET. And basically what automated ML does is, like I told you, you might go back and forth trying to, choose an algorithm, evaluate your model, and that process is very iterative and very experimental. What AutoML does is it allows you to sort of bootstrap and automate that process where it will automatically search different algorithms and different hyperparameters to try to find the best model for you without you having to specify what the best model might be, right? So it's just going to automate that process, and it's really good for beginners, right? So if you're a beginner, you don't really know where to get started, it automates that process for you and sort of provides guidance on how to get started. But if you're an experienced professional as well, right, it also saves you time in terms of automating that process of training a model. So we're going to import those packages. We're going to define the schema. This is basically what the inputs are going to look like for our model and what the output is going to be once the prediction gets generated. We're going to initialize an ML context, which is the entry point for all ML.NET applications. We're going to go ahead and load our data. It's usually a good idea to split our data into training and test sets so that we can perform that evaluation that I mentioned earlier. And then all we're going to do is we're going to say, create a regression experiment. We're going to tell it, train for 5 minutes. This is 300 seconds, right? I want you to train on my training set. And here's the column, right? The inspection score. That's the one that we're trying to predict. Now, go find me a model. Okay, after 5 minutes, it's going to come back and it's going to give me some model, right? And it's sort of stored in this best run model property here. Then what I'm going to do is I'm going to use that model to make some predictions. And then I'm going to compare the inspection score, which is the ground truth, against the predicted value, which is the score, right, on those predictions. And when we print out the metrics, you can see that these are the common metrics for regression type problems. It has an R squared of a very common metric here. This R squared is 0.74, 74%. So it's not great, but good enough for demo purposes. We're going to try making a prediction. Again, we create an instance of that, that sort of, we create a data point here, right, with model input. We create a prediction engine, which is a convenience method for creating predictions. And then we go ahead and predict, and you're going to see that this is the ground truth, 11, and this was our prediction, 11.56. So pretty good, right? Okay, so now we've prepared our data, we've built a model, and we've trained a model, and now we're ready to deploy and get this model out into the world. So how do we do that? Well, here I have a web API that was built with Saturn. So you heard about Saturn, the safe stack in previous talks. So this is essentially a Saturn web API, which, if you're familiar with ASP.NET, ASP.NET Core, this is going to look very familiar. You have a configuration. In this case, I set up a configuration module here, which all it does is I'm registering a service called Prediction Engine Pool, which essentially just creates an engine. It creates an object pool of prediction engine objects. And what this does is it makes the prediction engine convenience API for making single predictions. It makes it scalable, right? So you can handle multiple requests at the same time. And we're going to use that inspection model .zip file. So something I skipped over was when we saved the model, we saved it to this file called inspection model.zip. It's basically just a serialized version of the model that contains information like what your inputs are, what your outputs are, and what transformations are going to need to take place to make predictions and things like that. So we're going to be using this inspection model zip file, and we're going to be again registering the service that we're going to use inside of our handler for making predictions, right? So we're going to use dependency injection to basically get that prediction engine pool. We're going to call predict on that, on the model input that's coming in as a JSON request, and then we're going to write out the response to the client, whoever is making the request, right? We're just going to define our routes here. It's going to take a post request to the predict endpoint, and it's going to use that prediction handler, and then just configure this and run it, right? So now we have a web API. Cool. If we were to run this locally, it would run just like an ASP.NET application, listen on port 5000. Great. But wait, there's more. In the previous talk, you saw how you could use Farmer for automating deployments and sort of orchestrating deployments to the cloud. So the next step is, okay, this model's not doing so much for me locally. Let's deploy it to the cloud. So to do that, I have a Farmer script here, which essentially goes over through those building blocks that the previous speaker sort of talked about here. And basically, I set up a web application. I define my ARM template, the location that I want to deploy it to, and then I tell it, hey, deploy my application. So once my application, after a few minutes, it's going to go scaffold my project, deploy my application, and I'm going to get a URL that I can make a request to. So if we use that same input, right, that we used in that notebook to make predictions, we can make a post request to that endpoint, right, to that predict endpoint at this URL. We can go ahead and hit send. Now, this might take a while because it probably fell asleep between the last time that I tried this, like the web service fell asleep, right? This is a service I had already deployed. But you're going to see that after a few minutes, because it's cold starting, right? It's going to take a few seconds actually. So after those few seconds, what's going to happen is I should get a response. You probably can't see it here because it's super transparent. But essentially, I should get that response at some point, and then any subsequent requests that I make, it's going to take significantly less time to sort of process. So yeah, so there it is, right? So there's that response. That's my ground truth, and this is the prediction. And again, as I showed you, right? If I were to do that again, it basically comes back instantaneously. So that does bring me to the end of my talk here. Let me go back to this here. If there's any questions, you can check out the resources here, and I'll take any questions if there are any.
Thank you so much, Luis. That was amazing. Unfortunately, we don't have any time for questions, but there are a few on Twitter. If you want to go head over there and search the hashtag .NETConf, there are a couple questions you can answer.
Cool. Yep. All right. I'll check those out. Thank you.
Thank you so much, Luis. This was amazing. And for those who are getting started with .NET F Sharp or know of anybody who is, please don't miss me and Luis tomorrow, 8:30 a.m. Pacific on Learn TV. Yep. Thank you so much for the Let's Learn .NET F Sharp event. Thank you so
Awesome.
much.
Thanks so much. See you folks tomorrow.